Hello, sixth graders. Welcome to Areas of Parallelograms lesson. Pause while you write the lesson title in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is, I can find the areas of parallelograms by completing practice problems with 100% accuracy in multiple attempts. Here's the standard we'll be addressing today. It is, find the area of regular and irregular polygons by composing into rectangles or decomposing into triangles or other shapes. We're going to start today with a quick vocabulary review and a key idea. The area of a polygon is the amount of surface it covers. You can find the area of a parallelogram in much the same way as you can find the area of a rectangle. Your key idea is area of a parallelogram. In words, we say the area of a parallelogram is the product of its base and its height. Algebra, it looks like capital A equals lowercase b times h. So area equals base times height. Be sure you get this into your notebook accurately. Example 1, finding the areas of parallelograms. We're going to find the area of each parallelogram. So we're looking at example 1a, and we need to remember that area is measured in square units. So a linear unit would be something like 14 meters and 12 meters. Square units is what you get when you multiply two of those together. You get square meters. So our first step is always to write the formula. So area equals base times height. We're going to write that formula in our notebooks, and then we are going to substitute in those values. So the base is 12 and the height is 14. So we substitute in 12 and 14. We're multiplying those together. And then our third step is we multiply and we get 168. So our answer is the area of the parallelogram is 168 square meters. Now let's take a look at example 1b. This is also a parallelogram. It's just turned a different way than what we're used to normally seeing it, and that's fine. So we're going to find the area of our parallelogram. Again, our first step is we write the formula, and then we substitute in the values. So our base is 8.5 feet, and our height is 4 feet. And we multiply those together for our third step, and we get 34. So our answer is the area of the parallelogram is 34 square meters. Let's look at example 2, finding the area of a parallelogram on a grid. So sometimes we're given a polygon and it's shown to us on a piece of grid paper. So I'm going to help you learn how to count the lines and the spaces on there. So it says we're going to find the area of the parallelogram. We're going to count the grid lines to find the dimensions. So it says the base is 2 units. So when we're counting that, we count from corner to corner. And so we count 1 unit. So we count the space from one corner to the next, and then the space from the next corner to the next corner. So that's 2 units. And then finding the height is a little bit trickier, especially with this one because it's so tall and skinny. So we can draw a line down from the top all the way to where the bottom would be if it were a square or some other shape. And then we can also count from corner to corner. So we can put a little mark up there. 1, 2, 3, 4, 5 units. So our first step is write the formula, and then we substitute our values. So our base is 2 and our height is 5. And then our third step is we multiply. So the area of the parallelogram is 10 square units. For example 3, we have a real-life application. You make a photo prop for a school fair. You cut a 10-inch square out of a parallelogram-shaped piece of wood. What is the area of the photo prop? So we're going to first convert the dimensions of the piece of wood to inches, and that's because this is in inches, so we want everything to be the same unit. So there are 12 inches in a foot, so the base is 4 times 12, which is 48 inches. And the height is 8 times 12, which is 96 inches. And here the book is having us use a verbal model to solve the problem, which is one way to do it. So it says the area of the photo prop, which is what we're looking for, so we don't know that, there's nothing underneath that, equals the area of the wood, which is 96 times 48. So remember, 96 was our base, 48 was our height, minus the area of the square. Well, the square is 10 times 10, so it's 10 squared. And so we're substituting in our values, and then we evaluate the 10 squared, so that's 100. And so now we've got 96 times 48 minus 100. And when we multiply 96 times 48, we have 4,608. And we've still got our minus 100. And then we're going to subtract that. So we have 4,508 square inches. Remember, to earn full credit for your lesson, you need to complete your notes in your ISN, complete the Google form questions, and review your lesson if you need to. Also, complete your Big Ideas math assignment in your math spiral notebook and submit that when it is 100% correct. Be sure you track your progress on your playlist.